Proper installation of Roots rotary meters helps maintain their accuracy and promotes long meter life. This video describes how meter design and operation affects installation. It also shows the steps in proper installation and removal of a Roots rotary meter. Inside the rotary meter, two counter-rotating lobed impellers trap and pass fixed volumes of gas through the meter from the inlet to the outlet. The clearances between the rotating impellers and between the impellers and the meter casing effectively isolate gas at the inlet from gas at the outlet to prevent any unmeasured passage of gas through the meter. The only gas that passes through is the fixed volumes swept through by the impellers. One complete revolution of the two impellers measures and passes 4 fixed volumes of gas. By counting the rotations of the impellers, the meter counts the number of fixed volumes of gas passed through the meter. Typically, meters are sized for the total connected load, delivered at the minimum metering pressure. In many cases, the total load will have many components, as in installations with multiple boilers, apartment complexes, or anywhere a large number of gas-fired units are downstream. Diversity factors should be used to prevent the meters from being oversized. Often, only a few of these would be online at any one time. Actual consumption would only be a fraction of total load, and a meter size for total load would be oversized. Engineers calculate diversity factors that reduce total load and prevent the meter from being oversized. Roots manufactures a wide variety of meters for different flow rates and different applications. A straight counter meter like this one counts only the displaced volume. It's used where pressure is low or the pressure is constant. Some applications involve temperature and pressure correction of measured volumes. Gas volume changes with temperature and pressure, so measured gas volumes are often corrected to volumes at standard temperature and pressure. As temperature increases, the amount of gas in the measured volume decreases. Because there are fewer molecules in the measured volume, less gas is going through the meter in each measured volume. Temperature-compensated meters adjust for differences between the temperature of the measured volume and standard temperature. Temperature compensation reduces or increases the count readout to correct for the amount of gas in each volume. Temperature-compensated rotary meters have two counters, one uncorrected readout like the counter unit, and another that displays temperature-corrected readings. Temperature-compensated meters are used where gas temperatures can vary significantly. A 5-degree variance from standard temperature equals a 1% change in volume. Instrument drives, such as this, provide an output shaft to transmit the meter drive rotation to instruments that can calculate and record the volume passed through a meter. Instrument drives can be mounted on both temperature-compensated and uncompensated meters. They are used on uncompensated meters when pressure is subject to change. They are used on temperature-compensated meters when both temperature and pressure are subject to change. Instrumentation may perform its own temperature and pressure calculations or simply record the information for later calculation. To install a rotary meter, you need to be able to identify certain important parts. These include the inlet and outlet, the gear end, where precision gears provide timed, coordinated rotation of the impellers, and the counter end, which has a magnetic coupling to transmit impeller revolutions to the counter or instrument drive. Pressure-tight covers enclose both the gear end and the counter end. A counter unit on the counter end of the meter records impeller revolutions transmitted by the magnetic coupling. Gearing in the counter unit converts the displaced volumes to standard measurement units, such as cubic feet or cubic meters. Pressure taps on both the inlet and outlet sides permit testing and pressure compensation connections. Sight gauges on both end covers show level of lubricants. Sometimes an instrument drive and adapter are attached to the counter end. The adapter lets you mount different types of instruments to the meter, like this one. Instrument drives and counter assemblies are lubricated. The plastic housing on a counter assembly has a window and fill line. The counter also has test dials to check rotation and provides a visual verification of meter rotation. While Roots rotary meters are designed to let fine materials in the gas stream pass through, it's important to prevent trash from entering the meter. Very small particles and viscous materials, such as lubricants and sludge, can interfere with the clearances between moving parts. This can prevent the impellers from spinning freely. Avoid placing a meter low in the piping where the buildup of fluids could damage the meter or add resistance to flow. Also, avoid slanted installations that would prevent proper lubrication and produce uneven wear. And avoid placing excessive stresses on meter housing. Too much stress could produce binding or wear and could structurally damage the meter. Roots recommends 2 mounting positions. This is an example of top inlet mounting. It's also called vertical installation because the gas flows vertically or downward through the meter. When the meter is mounted vertically, there should be no lubricated valves directly above that might contaminate the meter with grease. Side inlet mounting is also called horizontal mounting because the gas flows horizontally. The flow should be from left to right when facing the drive end of the meter. In both cases, the rotor axes are parallel with the ground. Meters in either installation should be in an isolation bypass. Of the 2 mounting positions, vertical installation is preferred because gravity helps pass dirt or scale through the meter. Other piping layouts based on established practices may be equally satisfactory, especially if a strainer is used ahead of the meter. The first step in installation is unpacking and checking the meter. Read the label to confirm that the meter size and type match the application. Check the inlet type, horizontal or vertical. Confirm that the meter's size matches the application. Next, remove the inlet and outlet covers. Give the impellers a turn to check that they rotate freely. Confirm that the location is properly piped. Piping should conform to company standards. Because it's important to keep any debris out of the meter, you should clean the piping on both sides of the meter. Remove any liquids, trash, or dirt and foreign matter from the piping. Blow the piping clean. You can blow the piping out with gas by opening the inlet and outlet valves. Small pieces, just a few thousandths of an inch in size, are more likely to jam the meter than larger objects. Smaller materials, especially pipe soap, welding slag, tape, sealant, or dirt, could get caught between the impellers and the meter housing, preventing the impellers from rotating. Once the piping has been cleaned, set the meter in place. Check that the arrow indicates proper flow direction. Inspect clearances to confirm that the meter will fit into its location and bolt down without excessive stress on the meter housing. Typical problems to watch for include too much space between pipes, misaligned pipes, out-of-level pipes, and lack of support for the pipe or the meter, which can cause the line to sag. Support is also important for larger foot-mounted meters. Foot-mounted meters should be placed on concrete pads or metal frames. The entire area of the base should be supported. Foot-mounted meters should be leveled in both directions to within 1/32 of an inch per foot. However, meters should not be supported by anchoring bolts or leveling screws. After a meter is leveled, shim or grout under the feet and back off the leveling screws. With line-mounted meters, the next step is to level and bolt the meter onto the flanges. Each screw should be coated with an anti-seize compound. The meter should be level in both directions to within 1/16 of an inch per foot, which is level to the eye. Any greater variation would be obvious, If the meter cannot be leveled, contact your supervisor for instructions. Dresser recommends installing 1 or 2 flexible couplings that can compensate for misalignment and absorb vibration. Flange bolts should be torqued to not more than 80 foot-pounds for the 5/8 11 cap screws. Get the specs for other sizes from your manuals. Install any test plugs in the pressure taps. Installing them now eliminates taking the meter out of service later to install them. Now that the meter is in place, confirm that the installation has not bound up the impellers. At this time, the system should still be open to the air. If not, turning the impellers may build up pressure that retards impellers, but you can still feel any binds or contact. Remove the socket head plug in the gear end of the meter and rotate impellers with a screwdriver inserted in the slotted clamp. They should still turn smoothly. Do not attempt to perform this check if the meter is under pressure. If you have received your meter without an instrument drive, install the instrument drive now, ensuring that it is set for the proper inlet orientation. If you've received the meter with an instrument drive installed in the incorrect orientation, you can change it by removing 4 screws and rotating the support housing 90 degrees. With the gear end open, fill the end reservoir with lubricant. Add oil into the reservoir until the level comes up to the center of the sight gauge. While this meter is installed horizontally, another sight gauge indicates the oil level on vertical installations. Next, replace the plug. Plugs must be set tightly to 5 to 10 foot-pounds of torque because the meter end reservoirs are pressurized during operation. The magnetic drive end cover is also a pressurized reservoir and is filled the same way. The instrument drive, or counter spur gear bearing sump, is also an oil reservoir but is not pressurized. The oil fill screws should be tightened to the O-ring seal on the screw and then turned 1/4 turn more to secure. Now the meter is ready to be pressured up. Following company procedures, first purge the system of air. Open the bypass valve if it is closed. Open downstream needle valve. And crack open the upstream block valve to slowly build pressure and purge air from the meter and the pipe loop. Sudden flow could make impellers spin too fast. When the meter is fully purged, close the needle valve. Slowly open the upstream block valve the rest of the way. Slowly open the downstream block valve. Now, slowly close the bypass valve. Listen to the meter for any knocking sounds which would indicate overspeeding or sudden pressure surges. Follow company procedures to confirm that all connections are gas tight. Next, you need to make sure the instrument drive is turning in the right direction. Check the top of the instrument drive. A rotation arrow has been drawn in the housing. The shaft should turn in the direction the arrow indicates. Incorrect rotation means you must change bevel gears as your manual indicates. If the meter is working properly and the drive is rotating as it should, you can install the instrumentation. The meter must not be rotating. To stop the meter, first open the bypass valve. Close the block valves to stop meter rotation. A drive dog is used to transmit movement from the instrument drive to the instrumentation. To attach the drive dog, position it on the shaft and insert the shear pin. Position the adapter plate on the support housing and check the clearance. The drive dog pin should be approximately 11/16 of an inch above the surface of the adapter plate. Install 2 cap screws and tighten. Now, install the instrument with cap screws. When this is done, you're ready to open the block valves and close the bypass. When the process is online, use counter readings to confirm that the gas flow does not exceed the rating of the meter. Removing a roots meter follows a similar but reversed procedure. First, take any readings needed to calculate the gas volume that will be bypassed while the meter is being removed and replaced. Calculate the flow rate and note the time. Next, depressurize the meter, following company safety procedures. After the meter is depressurized and the impellers are stationary, remove any instrumentation by loosening the screws that attach it to the adapter plate. Before removing the meter, the 2 ends and the gear drive sump must be drained of oil using an approved container. Put the plugs back in place when you're done. When the oil is drained, you can unbolt the meter. When the meter is removed, cover the inlet and the outlet. Follow any other company practices that might be required, such as estimating the volume bypassed during removal and installation. The new meter can now be installed as discussed in the installation procedures. That's how straightforward it is to install and remove Roots rotary meters. A little care goes a long way toward maximizing the life and accuracy of your meter.